Formulas and substitution. A formula is a literal equation that describes a relationship between two or more variables. Literal means that it uses letters. Formulas are used in mathematics, science, economics, the construction industry, food preparation, anywhere that measurement is used. Formulas can be very useful in our everyday lives. We could use a formula to figure out how much fertilizer to buy for our lawn or garden, to find the average speed traveled on a trip if the distance and time are known, and even to change a Celsius temperature to a Fahrenheit temperature when we're visiting a foreign country. To use a formula, we replace the letters in the formula with the measures that are known. Then we solve the equation for the measure we wish to find. First, let's find which measures we know and which is the unknown measure we need to find. We are told that D is 36 and R is 9. The unknown variable is T. When we substitute numbers for the letters that are known, the equation looks like this. 36 equals 9T. Then we can divide both sides by 9 and we find that T equals 4. This formula, D equals RT, relates distance to rate and time. Distance traveled equals the rate or the speed multiplied by the time. It could be describing a bike ride of 36 miles at a speed of 9 miles per hour. Solving the equation shows that the time for this ride would be 4 hours. Let's look at example 2. Use the formula D equals RT to find the distance Anthony traveled after driving for 2.5 hours at 60 miles per hour. Explain why your answer is reasonable. Well, first of all, we start out with our formula D equals RT. When we substitute numbers for the letters, we can see that we know what the time is, 2.5 hours, so we substitute that here for the T. And we know what the rate or the speed is, 60 miles per hour, so we can put that here. These numbers are in parentheses to show that we're going to multiply them. The unknown is the distance. The question asked, find the distance. Our next step, after we substituted the numbers for the variables that we know, our next step is to rewrite the numbers as improper fractions. So our first number here, 60 miles per hour, we've rewritten 60 miles over 1 hour. And then we converted this 2.5 hours to an improper fraction, 5 hours over 2. Remember, when you convert an improper fraction, a mixed number to an improper fraction, you multiply the denominator times the whole number and add the numerator, which gives us 5. Now we'll do the multiplication. We start by canceling where we can to simplify our multiplication. So we see that there are hours above and below the division line, so we can cancel those out. Cancel the units, and then we see that both 60 and 2 are divisible by 2, so we'll divide those. 2 divided by 2 is 1. 60 divided by 2 is 30, which leaves us with a simple multiplication problem. D equals 30 times 5. We see that the answer is D equals 150 miles. Anthony traveled 150 miles on this trip. All right, example 3. Alexandria biked 64 miles in 4 hours. What was her average speed? Now, during her bike ride, Alexandria may not have traveled at a constant speed. Some stretches may have been fast and others slow. Her average speed is the rate at which she would have completed the trip if she had ridden at a constant rate. We can find the average speed with the distance formula. We are told the distance and the time. So we start with our formula here. D equals RT. We substitute the things that we do know, 64 miles is the distance, and 4 hours for the speed or the rate. Oh, wrong. 4 hours is the time. Okay, so we have the distance, D, and the time, 4 hours. The rate, or the R, is what we're looking for. That's the unknown right now. So we set up, in order to isolate the R, the unknown, we need to divide both sides by 4 hours. This is a multiplication problem right here. We use the inverse operation, division, to isolate the variable. So here we've set up our problem and dividing both sides by 4 hours. So on the right side of the equation, 4 hours divided by 4 hours leaves us with just R all by itself. So we've isolated the variable R. Over on this side, we're going to divide 64 by 4, and we end up with 16 miles per hour. So Alexandria's average speed was 16 miles per hour. The rate at which she rode may have been faster at some points and slower at others, but averaging 16 miles per hour for 4 hours, she completed the 64-mile trip. Example 4. Use the formula F equals 1.8c plus 32 to find F when C is 37. So this formula is used to convert measurements of temperature from degrees Celsius to degrees Fahrenheit. We replace C with 37 and simplify. So here is the original formula. Here we've substituted 37 for the C. Notice in the formula 1.8 is right next to C. That means to multiply. So here we set it up as a multiplication problem. In the next step, we've multiplied 1.8 times 37, which gives us 66.6, and the final step is to add 32. Our answer is 98.6 when we add those two together. So you could use the same formula to convert from degrees Fahrenheit to degrees Celsius, in which case you replace the F with the number of degrees Fahrenheit and solve for C.